Let's now implement the logic behind the crates. So the first thing we're going to do, we're going to go under MicroBots and Scripts, and we're going to create a new asset of the type script that we're going to call collectibles. And collectibles will need a onUpdate event, and this collectible script will be attached to our MicroBots scene. So I'm going to go under Properties and Scene, add a new thread, open it up, and drag and drop collectibles here. Back in the code editor, I am going to first declare one or two variables here, one for my initialization and the other one that is going to be the array of crates that I'm going to gather. So I'm going to add on the update the following code. If I am not initialized, then in the local variable scene, gather the this keyword, which is basically the scene, since it is the one that triggered the event. For each object in my scene, pick them up one by one using their index. And if the object name contain crate items, which is the identifier that each and every our crate will contain, crate item ammo or crate item health. If it contains crate items, then I am going to run some extra code here. I'm going to close this and init equal to true. So this code will only run once. Next, for the code inside the if, we are going to create a few more blocks. First thing that we're going to create is to handle the block for handling the rotation. We are going to try to grab the variable rotation z for that specific crate. And if it doesn't exist, we're simply going to create it. And since we're initializing, we're going to give it a random value from 0 to 360. For handling the hovering, we are going to have this block here that is going to act as follow. If the variable location z does not exist, we're going to create it, and we're going to create a vector 3. In the x component, we are going to generate a random value from 0 to 1 that is going to tell us the amount that we need to go up or down. The y component will be used for our direction. We are going to randomize a 0 to 1 number. If it's greater than 0.5, we're going to go by default up. Instead, we're going to go down, -1. Next, we are going to store the z location of the crate at initialization time. And we are going to offset it by its bounds size multiplied by 2. When we are going to, I'm going to enter edit mode, shift and 1, enter wireframe. We're not going to place these crate one by one on the floor and ensure that their height is perfect for the hovering. What we're going to do is later on going to select them. Using the grab button, we're simply going to drag them like this, duplicate and drag them like this around the map. If we have a look here, they're going to be stuck here on the ground since their pivot point is at the center. So with this code, we are going to slightly offset them on the z-axis and ensure that they're going to be able to hover properly. Next is the respawn block. We're going to get the variable called respawn. If it doesn't exist, we're going to create a float value that is going to contain a value in second. If the object is not visible, the crate is invisible because it has been picked up by a player or non-player character. It will then decrease until it gets back to 0 and pop back up again to be picked by either the player or the NPC. And after that, we are done with this code. We are going to add the object inside our array, and we are going to ensure that this object is actually visible. The next part of our logic for the collectibles are going to be to handle the rotation and hovering method, as well as the respawn. So what we're going to do here, for each crate that we have stored inside our array, we're going to check first if the crate is visible. It means that have not been picked up. If it's the case, we're going to grab the rotation z variable and the location z variable. We are going to grab the basis matrix of that particular crate, and we are going to use our rotation z as an accumulator to rotate on the z-axis that crate by 45 degrees per second. We're going to create a assign the rotation Z to that crate using the basis matrix. Next, we're going to handle the hovering part. So we're going to use the vector 3x component to accumulate our delta time multiplied by our direction, either 1 or -1 up or down. If my location z vector 3 component x is greater than or equal to 1 or less or equal than -1, it means that we have reached the end of our cycle. We're simply going to invert the y component. So we're going to go from up to down and from down to up over and over and over. And finally, we are going to use that accumulator here that we are going to assign to the z component of our translation for our crate using the basis matrix. So the z component of our model matrix will be the z that we have stored previously plus the x component that we have just calculated here multiplied by a little threshold. So the rotation is not going to be too much. So if we got the opposite now of this condition, the crate is actually not visible. What we want to do is grab the respawn variable, and this time we are going to decrease that respawn variable by the application time, and we're going to ensure that it stays at 0 here. And if the respawn variable is now at 0, we are going to put that crate visible back. And now the next time around, we're going to enter this condition here. It's still going to start rotating and hovering. So this is done for this part here. If I push play, if I push the build button and then I push the play, we see that our crates are rotating and hovering properly. Next, we need to implement the code to actually pick these items. So I'm going to go back in my scripts folder and I'm going to create a new script that I'm going to call collect items. And this script will be assigned to each and every bot controller that we will have from now on. And I'm going to create the onCollide event. And I am going to select my bot controller because it's the object that the empty that contain our capsule object collider. And under object properties, I'm going to add a new script and I'm simply going to drag and drop collect item in the slot here. And I'm going to open it up in my code editor. And the code is going to be pretty straightforward. What we're going to do here, we are going to try to analyze from our contact here, since a contact involved two physical objects, and the object that trigger that event is our bot controller. So we're going to check if the event object name, our bot controller, is equal to the first object involved in the collision. If it's the case, this is the controller. On the other way around, we are going to check if the object name is different than our first physical object. And if it's the case, it means that it is the item. We can test that right away by printing the controller name and printing the item name on the console and put a new line here. I am going to build. And if you remember the way we have set up those crates, they do not respond to contact. So it means when my bot controller is ramming them, they're not going to start flying around. They're going to act like a ghost object that will just stay in place. So you can see now on my console that my bot controller is colliding with our collision map, which is predictable. And if I move around and go near my crate here, we can see that now the bot controller is colliding on top of my collision map. It is also colliding with my crate item ammo. I'm going to repeat the same process for here, and we can see that now we are having the crate item health. Next, what we're going to do, we are going to analyze using a string find to check if the crate item that we hit is a health or a crate item is ammo. And we're going to add, if you remember, when we deal with the bot, we have a action controller that contain the variable health and ammo. And we are going to pick them up and assign and add to the proper one based on the crate that have been picked. So this is the code that we're going to add. Once again, very straightforward. We are going to first check if the item is visible. Visible means that we can actually pick it. And we find in the item name the substring crate item. It means that we hit either one of them. Or So we are going to pick up the bot since it's our bot controller that is triggering the event. Our bot is the first attachment of our bot controller. And now in the item name, if we found the substring health, we are going to grab the health variable. I'm going to put it down as I'm going to test that right now, and the ammo as well. And we are going to pick up the health variable of our bot. And if it's the case, we're simply going to add 50 to it and make sure that it stays in the range of 0 to 999. Then we are going to pick our item and make it invisible. And we are going to assign an amount of time in second to the respawn variable of that item. I want to test that right now. So I'm going to put 3 seconds and comment that. I'm going to do the same for the ammo, 3 seconds, and I'm going to comment that. As you notice, also by default, the values that I put as a starter, the health give back 50 and respawn every minute. And the ammo give 25 and respawn once every 2 minutes. So I'm going to compile that and I'm going to test that right now. And we are going to see also if the code that we add in collectible is working properly. So I'm going to head over to my ammo. And you can see that now my ammo have increased 1, 2, 3, and it's popping back. I'm going to redo the same process, this time aiming for the health crate. And you can see that now my health is at 99 and the crate actually popped back. I'm going to restore back to 100%. And this is basically the only code that we're going to need to handle our collectible. Ensure that you restore back the 1 minute and 2 minute timeout for these crate. And we are going to stop temporarily this collectible script and ensure that our crates are placed on the ground. And we are going to restart here and we are going to keep that off as we are going to later on drag and drop those crates. And then when all crates are in place, we're going to restore that. Instead, as we're adding and restarting the collect item script, the collectible script, our crates will keep adding up. They will just keep stacking. So we're going to turn that off for now. We know that the code is working. Collect items also is in place. And later on is going to give us the freedom of drag and dropping, duplicating and drag and dropping and placing these crates at convenient location throughout our level. Let's now implement the necessary code to be able to shoot. What we're going to do here, let's bring our robot down. Here you go. And what we're going to do, we want to align a ray to be pointing in the same direction as our camera. So what we're going to do, we are going to select our camera here and start to have a lot of lines around. So we're going to make sure that we aim for that little arrow that is going to select our camera, push dot to focus it more clearly. And I'm going to push M to move the cursor to that location. Next, I'm going to go under Object, Add to Render Layer, and Ray of the type World. And I have now a ray object created. Selecting that ray object, I'm going to go under Properties and Object. And I'm going to rename it to be Gun Ray. And I'm going to access the ray properties. And I want to make sure the type is world, yes. And the length, I want the length to be the same as the clip end as my camera, which is 250. I want the update rate to be 10 Hertz. So I'm going to shoot 10 bullets per second. And I want in the configuration to be a single ray, return me the first hit with my physics world. And I am going to make sure that my ray interact with my first collision layer here. And as I do that, if I now push the play button, I can see that now I have a hit straight down on my collision map. Now the idea is to synchronize this ray with my camera. So what I'm going to do, I'm simply going to create a parent-child relationship with my ray selected. I'm going to hold shift and then maybe stop moving that camera for a second. And with my ray selected, I'm going to hold shift and then select the arrow on top of my camera. And I'm going to go under Object and Attach to Active. And right away, we can see we got that dashed line here that tells us that we got a relationship between the ray and the camera. I'm now going to select the gun ray. And under Properties Object, I'm going to change the transformation orientation to be in local space, and I'm going to zero out the location to make sure that it is at the same location as my camera, and also the rotation to make sure that it look at the same direction as my camera. With that set up, I'm going to start pushing play again, and we can see that now the ray is hitting my collision map wall here. If I push spacebar, turn around a little and try to aim at my crate, which also contain a collision object, I am going to now, did I hit? Yes, I can see here that I'm actually hitting the crate. The idea is based on the object that is currently hit by the ray, we are going to check if the substring bot controller is actually found, the object name. If we found bot controller, it means that we are shooting at another robot, another non-player character robot in this case. So we're going to start implement that in code. Now we are going to jump back to our bot controller, and we are going to add a new variable here, local, that I'm going to call shoot, and I'm going to set to 0 by default. And also I want to implement in the similar fashion that I implement the walk motion. I want to have a shot motion that is going to make my gun going back and forth. So I am going to create a new variable that I'm going to call shot motion that is going to work the same way as walk motion. And now I am going to create two new events for my mouse. When I click on my mouse button and move, rotate, I am going to change the camera direction, the view direction. And now what I want is when I double click or double tap on screen later on when we are going to implement the control for touch screen, when I double tap or double click, I am going to start shooting. So I am going to jump over to my on touches move event, and right below that, give it a bit of space, I am going to add the following code. On touch began, if my tap count is greater than 2, set shoot to -1, that is going to tell my code that I want to start with shooting right away. Since we're shooting 110 bullet per second, 100 millisecond of difference between each bullet, I want to make sure that I'm going to have a signal that is going to tell me that I want to start shooting now, not after 100 millisecond after I push the actual button. And as I release the button, I'm going to set shoot back to 0. Stop my gun from shooting right away. Next, I am going to move on and implement my gun shoot motion. So I'm going to jump over to my bot on update function here, and right above the walk motion, I'm going to paste this piece of code. So shoot motion equals to shoot motion plus my application delta time multiplied by if my shoot value is greater than 0, 50 to make it go faster, or simply use my current motion speed. And then shoot motion will be normalized. We're going to use a sin curve, just like the way we did for walk motion. So to stay clean, that's what we're going to do. So mat.sin, and then I'm going to copy my shot motion and paste it here, and done. At this point, I am going to be able to have my motion kicking in. If I go there and I start moving, we are going to start seeing that the gun is also moving slightly forward and backward, not only up and down as it did previously. So we're adding an extra motion here. And on top of that, what we're going to do is we are going to now change the bot controller function to accept extra parameter. But for that, we are going to need to have the actual target that our gun, the center of the screen here, is pointing at. So what we're going to do, we are going to bring in another block of code. This time is going to be to analyze the current target. So we are going to get our gun ray attachment of our camera in the similar way that we have done above, using the get attachment helper function to get the blaster here. We are going to get the gun ray simply by analyzing the substring in the attachment of the camera and return us the attachment that correspond where this string can be found. So next we are going to access the actual ray hit result, and we are going to check if we have a hit count greater than 0, we are hitting something. Then give us the object, the actual object that we're hitting, not the physical object, the actual object that we're hitting, such as our crate or our collision map, the actual collider, not the actual collider, but the object that is actually connected to that collider, and assign it to target. If we don't have a hit, simply return nil. Next, we're going to need to change the way we are calling our controller, our bot controller function, to not only receive the controller and the axis, but also our shoot, our gun, and our target as well. So what we're going to do, we are going to update this function call here, and we are going to send over to that function the shoot, gun, and target, and this function will now return us the last time that we actually had a shot. We are going to analyze the current time in millisecond, and so like that we can check what is the current time minus the last time we actually shoot, and if that value is greater or equal than 100 millisecond, we're going to be able to shoot another ammo. So now I need to change my bot controller function, and I'm going to go up there, and I'm going to change my declaration first, just like this, to receive these parameters: controller, the axis, the gunshot, the gun object, and the target object. At the bottom of the function, give a bit of space here, I'm going to implement my last piece of code that is going to actually allow me to shoot. I am going to implement this block here. So gunshot is basically, first thing we do is we check the current time, the current time in millisecond. If our gunshot is less than 0, remember when we double click, we set shoot to -1. It means that we want to start shooting right away. Or the gunshot is greater than 0, we actually already shoot a bullet and we're waiting to shoot the next one. If my current time in millisecond is less than my last time, my last gunshot is greater or equal to 100 millisecond, then grab the ammo variable of my robot. If you remember, when we actually synchronize the action controller, we have now at the bottom of our member variable the number of ammo this bot actually can hold for the moment. So we are going to check now if we have an ammo value greater than 0 and our target is not nil. What is the name of that target? Based on this substring, if we found in the target name bot controller, it is different than nil. It means that we're shooting at another robot. If it's the case, our target is a bot controller, we're going to get the first attachment of that bot controller, which is going to be our bot, and we're going to get the variable health just the same way we did it earlier. And if the health of that robot is greater than 0, it means he's not dead yet. What we're going to do is we are going to subtract to the health 5 plus another random value of 5. So the minimum damage of one ammo will be 5 plus 5, and top damage will be 10. And we are going to minus that and ensure that we stay at 0. So if that the max value is 0. So if the health is now 0, it means the robot died. So we want it to stop moving right away. Even if it's in motion, he's running and we're shooting him, we want him to stop right away, regardless of the current linear velocity that this bot might have. We want him to dive straight on the ground. This is why we're setting his friction to 10 to make him stop right away. Next, I am simply going to decrease my ammo and make sure that I cannot go below 0. And now I'm going to synchronize my next gunshot by assigning the sync that we have here with my gunshot variable. And I am simply going to return it and will then be affected to my shoot variable here, and then so on and so on and so on. If I push build and I test this code, as I double click, I start shooting, and we can see that now my ammo is going down. And based on, now I do not have another robot to shoot at, but later on, the code that we implement to check if the target name is the bot controller will kick in and start taking, so our bot can start taking damage.